The views and opinions expressed in this program are those of the speakers and do not necessarily reflect the views or positions of any entities they represent. This program is intended for educational purposes.
You're listening to
आप सुन रहे हैं
तुम सुनो था
നിങ്ങൾ കേൾക്കുന്നത്
ನೀವು ಕೇಳ್ತಾ ಇದ್ದೀರಾ
Radio Azim Premji University.
It's a math world with Divakaran and Shraddha. Episode 1, Babylon.
Hello and welcome to It's a Math World, a podcast where we look at the evolution of math from a cultural and historical point of view. My name is Shraddha, and my role in this podcast is that of a very average student to a very erudite math professor at Azim Premji University. Please welcome Professor Divakaran. Hello.
Hello. It would be my pleasure to help you through this journey.
We're going to start from the start and we're going to look at how math in different civilizations was so magically same yet different. And today we're going to start with Babylon. This is exciting. Let's begin.
This is roughly in 1600 BC, which is like 3,500 years from now at least. And
I'm going to believe you because I wouldn't know 1000 BC how many years ago that is. So if you're wrong, I'm not correcting you.
yeah, it's like you have to just add 2000 to 2023 and 1600 and whatever you get, which is some 3623 if I want to be precise.
Precise, okay.
It's long ago, right? This is really long ago. It's of course, people from the dawn of humanity, people have been trying to figure out the concept of a number, right? Like from the time we were cavemen, we have been using numbers at this rudimentary level.
Right.
And in fact, there is enough evidence to suggest that yes, cavemen were using these ideas because we have bones with carvings on it and things like that. Clearly, they were counting. They were doing some form of counting.
Of course, the way we count now has changed. Back then, we would only say 1, 2, 3. And now we will say buy 3, get 1 free. The math has changed.
Yeah.
Right. So numbers, we've always counted.
So we have always counted. And in Babylon, there was a drastic shift from this rudimentary way of counting to something much deeper.
Right.
And this much deeper way of doing maths or representing numbers is what in current day language we call a place value system.
Right.
A place value system is something that we are all familiar, even if you don't know the
Ones
name.
place,
value.
tens place, hundreds place.
Yes,
right?
Exactly.
Yeah. I remember writing HTO when doing addition and subtraction. Always got yelled at for not leaving that space to write the carryover.
Correct.
Memories.
So this is called place value system because depending on where a number or where a symbol occurs, it has different meanings, right? Like 343, in 343, the first 3 represents 300 and the second 3 represents 3. So the meaning of the symbol depends on the place it occurs. So that's why the first 3 is in the hundreds place. So it's 300 and the second 3 is in the ones place. So it's just 3.
Right.
So if you notice what is happening is here we are using both addition and multiplication to represent numbers. It's a combination of addition and multiplication.
Right.
So we are doing 3 into 100 plus 4 into 10 plus 3. That's what we are doing. So there is a mixture of addition and multiplication that is being used to represent numbers. This system is what we nowadays call as place value system.
I have never even thought of it as a system really, because that's the only way I know it, right? 343. A system and how, it's actually quite magical that the same number can represent a completely different thing just by virtue of its position. But now I appreciate it a little more.
So you might have seen another system as well, which we typically use, especially when we write, say, Henry the Sixth or something like that. So there we don't write 6 and then TH on top of it. We write Henry VI.
Yes, because Henry I believed that names should be alphanumeric, like passwords.
I am also guilty there, to be honest, because I also, like, my name is Divakaran. My father's name is Divakaran. My grandfather's name is Divakaran.
From now on, we will address you as Professor Divakaran III. So we are in Babylon, looking at the Roman number system, immortalized in the names of kings such as Henry VI.
So here, when you write Henry VI, you just write V and I to
Right.
denote 6.
Right.
And many of you might be familiar that this is the Roman way of representing numbers. Like 1 was denoted by I, 5 was denoted by V, 10 was denoted by an X, 50 was denoted by an L, 100 was represented by a C, and so on.
And now that you mention it, I remember how in our question papers, there was this weird numbering system where they would say, question number 1 in Roman,
Mhm.
answer the following. And the following would be in 1, 2, 3, 4, 5.
Correct.
Right? And you'd be like, that's the main thing. So write it in Roman. Yeah.
Yeah.
Right.
So this like sometimes we use this mixture of these different ways of numbering in some
right.
sense. And in fact, in question papers, you also sometimes use alphabets to do the numbering.
Yes.
Right? So these are different ways of numbering in some sense. So this actually helps us realize something deeper about numbering. Numbering is nothing but a form of correspondence between two different collections. Right? So like A is 1, B is 2. We know that A is the first alphabet, B is the second alphabet, C is the third alphabet, and so on.
Right.
So counting is nothing but in some sense some form of labeling in.
But beyond 11 and 12, I'm guessing the Roman number system was really, really inefficient. Because who remembers it beyond 12?
So the reason why Roman numerals are not used so often is because it's very difficult to do arithmetic using Roman numerals. Like addition was still okay, but it's really difficult to say multiply LXVI and CLVII.
These are numbers.
These are both numbers.
Okay.
And of course, this is very difficult to even understand what these numbers represent, and multiplying them is much harder.
So I'm guessing it flopped really soon or died soon.
It didn't die so soon as we would have expected it to flop. It took humanity many, many years to come up with a better, more sophisticated way of representing numbers.
We were really slow then, weren't we?
So Babylonians were the first people to have come up with a place value system. Numbers were represented using a combination of addition and multiplication by powers of fixed number. So usually in the place value system that we are used to, we are using powers of 10.
Right.
1 can be thought of as 10 power 0. 10 can be thought of as 10 power 1. And 100 can be thought of 10 power 2.
Which means that if someone in Babylon had chosen not 10, but say 9 or 7 or 6, big numbers, the way we know it, would have been completely different.
Exactly. So if suppose you had chosen 9 as your base, this is called the base of the place value system, then 343 would mean 3 into 9 square plus 4 into 9 plus 1 into 9.
Wow.
And Babylonians did not use 10.
So what this really means is, let us say there are 20 mangoes. I know it's 20 because I'm counting in base 10. But he was counting in base 9. I would say I have
2 mangoes. What does that mean? I have 2 into 9 plus 2 mangoes.
I have two mangoes. But if you're an Indian, that's how you say 2 in base 10. I have two mangoes.
So there is a famous joke on this line. So you might have seen T-shirts with this. There are 10 people. There are 10 types of people. Those who understand binary and those who do not understand binary. Because in binary, 10 stands for 2.
That's a T-shirt the listeners of this podcast will understand. So why did the Babylonians really choose 60 as their base?
That is actually, people have been trying to answer this question for a long time, and there are different theories but we don't know which of these theories are correct. I can discuss the various possibilities that
Right.
might have led to this choice.
Right.
One choice is that the more number of divisors the base has, the better it is. Let's try to understand this clearly. Notice that I can represent 1 by 2 and 1 by 5 very precisely in base 10. Right?
Right.
1 by 2 is 0.5
Correct.
and 1 by 5 is 0.2. But on the other hand, if you look at 1 by 3, for instance, it's very difficult to represent this number in decimal,
Right.
in base 10.
Right.
It will be equal to 0.33333 and it does not end. So what is so special about 2 and 5? The thing special about 2 and 5 is that they are both divisors of the number 10.
10.
And that is why you are able to represent this manner.
Right.
Right? So what am I doing when I'm saying that 1 by 5 is 0.2? I am saying that 1 by 5 is equal to 2 into 10 power minus 1.
1.
In other words, it is 2 by 10.
Right.
Right? So this I can do only if 2 is a divisor of 10.
10.
Otherwise, this is a problem for me.
Right.
So the more divisors the base has, the better it is for me
Right.
to express these kind of numbers. And typically you would like to express at least 1 by 4 and 1 by like at least some numbers, 1 by 2, 1 by 3, 1 by 4 and so on.
And 60 has that. Has 2, has 3, has 4, has 5,
Has
has
6.
6. Oh, has 10. Wow. Yeah.
So that is the reason why a number with many divisors is a good choice.
Right.
So then you might ask, okay, then why did you choose 10? Humans have 10
10
fingers.
That's exactly what I was thinking. Yeah.
So that is more related to biology and not really the reason for the choice of 10 is not coming from a mathematical reason, but it's really coming from a biological reason.
Right.
But 60 on the other hand also has other like astronomical reason, for instance. So the earth goes around the sun in 365 days. It's actually not 365, but very close to 365 days. In earlier days, it was common to actually approximate it by even more crudely and say that it takes roughly 360 days to go around the sun. And this orbit can be thought of as a circle roughly. Now, it's interesting to notice, if you divide the circle into 6 equal parts, then the length of the chord that connects those 2 adjacent points has the same length as the radius.
Oh.
So 60 degrees, which is 1/6 of the total,
subtends a chord that is the same as the radius of the circle.
same as the radius of the circle.
Okay.
So this 1/6 of a circle, whatever angle that subtends, that was important in for astronomical
because that'll
reasons.
be an equilateral triangle.
That will be an equilateral triangle.
Right.
So that is why 60 became important, because 360 by 6 is 60. So 60 became important from an astronomical perspective.
Wow.
And this is why, if you notice, many of our, like say, time is 60. There are 60 seconds in a minute.
Exactly.
There are 60 minutes in an hour, and so on.
It's amazing because you think of math as an exact science, but it has been more useful in being approximate.
Absolutely. In fact, even today, I would say that in many times, what is important is to have a sense of things, right? Often I tell people, even if you don't know the exact multiple of 2 numbers, you should say roughly what the size of it is.
Right.
Does this answer make a logical sense?
Right.
Should your answer be less than 1 or greater than 1? Should your answer be less than 100 or greater than 100? At least this level of understanding you should have.
We will have that if math teachers can correct our answer sheets with this understanding. It's not exact, but she has a sense. It had to be 347, but she's written 344. We will give her full marks anyways. They don't check our math sheets like that, which is why, yes. But see, this is amazing. And I'm so glad that you agree that the beauty is not in exactness, but in having the right sense of things.
So these are all different aspects of mathematics, and I think estimation, approximations, these are deep and central aspects of mathematics.
Right.
Suppose you own a single screen theater, right? You own a single screen theater, and you have the ticket price is given to you,
right.
and you also have a parking lot. Okay, The parking lot has this many slots for four-wheelers, this many slots for two-wheelers. Estimate the amount of money that you can make in a month.
Is it a Shah Rukh Khan film?
So that's where you have to make assumptions. Right? Of course, not every film will be a Shah Rukh Khan film.
Right.
There will be flops, there will be big hits. So you have to estimate. So you have to make assumptions. So the answer that you will come up with will not be an exact number like 347, but something in a ballpark figure. Is it in the hundreds? Is it in the thousands? Is it in the 10,000s? Is it in lakhs? That's the kind of thing that we want to understand.
And that's the kind of thing that's driving economies today.
Exactly. There are areas of maths where you need to do exact stuff.
Absolutely.
And maybe the way to go forward is to have a good mixture of the different flavors of maths, right?
Right.
We all know that in probability we are not talking about exactness, right? So there are different areas of maths. They all have different flavors. It's very possible that the same person might not like one particular aspect of math but might like another aspect of math.
I think the love for statistics is a different kind of love for math.
Exactly.
But the love for rocket science is a different kind of math.
Absolutely.
Right.
It's like there are genres within films. Just like genres within films, there are genres within
This
maths.
is so cool to know. Yeah, what genre of math do you like?
Coming up on the other side of the break.
That is where the real brilliance of Babylonians come. They did not use 60 symbols.
Okay.
They actually had just 2 symbols.
It was just us who said, hey, let there be nothing also in the scheme of things.
Raga and nation. There is the music and there's the country. The music is a cultural composite. It has ideas from all across the breadth and width of India. The people of India, they are from very, very diverse backgrounds. We have a plethora of religious beliefs. There are any number of languages and cultures. We all have our unique ways of experiencing life, and music forms a very big part of these lives. The wonder that is India through the beauty that's music. Welcome to Raga Nation.
The Raga Nation with Raghavan Manian. Coming soon, only on Radio Azim Premji University.
So the Babylonians decided that they want to take the powers of 60, but now there is a hurdle in their path. What's the hurdle in the path? If suppose you want to use 60 as the base, then you need 60 symbols, right? Remember that because we are using powers of 10, we are using 10 symbols, namely 0, 1, 2, 3, etc. up to 9.
But did they know of 0 then?
They did not know of 0.
So they started with just 1.
They started with 1 and they had to go up to 60, right? If suppose they were using base 10, they should have used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They would need 10 symbols.
And just to reiterate this, when we are talking symbols, we're actually meaning the shape of 1, the shape of 2, the shape of 3, the shape of 4, the shape of 5, the shape of 6, the shape of 7, shape of 9, shape of 10. That's what we know now, and we don't need to know any more shapes.
Exactly.
But the Babylonian system using base 60 had to have 60 shapes to define numbers from 1 to 60. I don't know who loved math in the Babylonian age when we cannot find ourselves to love 10 shapes of math. This is amazing. But there were people who actually learned 60 shapes.
So that is where the real brilliance of Babylonians come. They did not use 60 symbols.
Okay.
What they did was they were very innovative in the use of these 60 symbols. They actually had just 2 symbols. They used these 2 symbols to construct all 60 symbols.
What did these 2 symbols represent?
1 and 10.
Oh.
The 2 individual symbols represented 1 and 10. And these two symbols were used to construct the remaining symbols.
numbers. Got it.
So that's what they were doing.
Right. So if they had to write 60, they would write 10 6 times probably.
Exactly.
Okay.
Exactly. Like the 1, 2, 3, 4, etc. were just dashes, like I. So 4 would be just I.
Oh.
So the symbol for 4 is something simple, but they wanted it to be one symbol, so they connected it in some fashion.
Okay.
So the symbols for 1 to 10, 1 to 9 were all constructed using one thing.
Right.
Then there was a special symbol for 10 as well. So, and every other number were constructed using the symbols for 10 and 1.
Oh, then these must be very long symbols, I'm guessing.
They were big symbols.
Yeah.
This is often the trade-off. You can either have a very short collection of symbols. If the symbols are simple, then you need many of them.
Right.
But if you want few of them, then the symbols have to be complicated. And this trade-off is something that we see in languages as well.
Right.
Germans don't mind length, but they don't like complexity.
Right.
Babylonians had a very similar philosophy. They said, it's okay if the symbols are big and long or we don't care about it. They are simple. And that's good enough for us. And anyway, in those days, not everybody used these numbers for calculation. There were people who were specialized in the task and only they did these calculations.
Oh, so they were able to do calculations even with this very cumbersome system of representing quantities.
They actually had algorithms to do addition and multiplications, which were quite similar to the algorithms that we use today. One issue was that, as we had mentioned earlier, they did not have zero with them. So this created some complications for them. So for example, how would you represent, say, 404 if you did not have zero?
Would they write 400 and then write a plus sign and then write 4? Would that be how they would do it?
That would have been a smart way to do, but that again is a little problematic because then you are not representing the number as a single numeral, but as a sum of two numerals. And often you want to write it as a single numeral. And this is something we would like to.
But if you're going to do that without a zero, there's going to be a lot of ambiguity.
This led to a lot of ambiguity, but they said, okay, fine, let there be some ambiguity. From the context, you should be able to figure out the meaning. Right? As I said, there should be a sense
of where you're going.
Roughly how the value should be.
Right.
So for example, they will write 44. Instead of writing 404.
So based on the context, you decide if I'm talking about the number of dogs in my house or the population of our village.
Exactly.
The context becomes very, very important here.
Exactly. So for example, 44 can be confused with 44, 440 and 404.
Right.
Right? So now you have to guess what is this thing. Or maybe 4004 also.
Right.
Or maybe 40,004 also.
Right.
We don't know. And we have to really understand what this is. So often, because they did not deal with as large numbers as what we deal with currently, it was easy enough to understand from the context what they stood for. But still, and sometimes they used this to their advantage also. Sometimes they wrote 44 to mean 0.44.
Yeah, especially when they're talking about how much money you owe me.
Exactly.
It's not 44, it's 0.44, man. Get the context.
So they use the ambiguity to, again, coming back to the point that you were raising earlier, often mathematics is about precision, right? But here again is an instance where ambiguity was utilized to the full power.
By the HR and payroll of Babylon. I accepted the offer letter thinking it's 44 lakhs, but no, it was only 44 rupees per annum. So when did the Babylonians finally touch base with 10 as the base for their number system?
No, they never switched to 10. The reason why we have 10 as the base, which is popular throughout the world, is because the people who invented 0, Indians, used base 10. So that's part of the reason why now throughout the world we use 10 as the base.
We were the biggest influencers. 0 came at the very end.
Yes.
Literally changed the way world spoke to each other, did business with each other, or kept record of things. Everything. Just changed with that one decision.
Probably when I say 15, you see it in your mind as 1 5.
5.
Right? You cannot So we have in our mind, in our culture, we have identified the number and the numeral so much. Right? We cannot distinguish between the number and the numeral. But these are two different ideas. But now we cannot even imagine a world without these numerals.
Right.
So that is how much the numerals have influenced our life. So in that sense, I would say that the discovery of the place value system and later the discovery of zero was really some of the greatest inventions of humanity, like at the same level as, say, maybe the wheel or fire or something like that.
Toothbrush. My goodness. But to get the entire world to agree on this one thing in the time that it was, when zero actually was shaped up, how did you think, how much time, how much effort? I cannot get my head around the fact that everyone just agreed.
It took centuries to have this transition. So the Babylonians came up with the place value system in 1600 BC, roughly that period. The Indians discovered zero and the place value system much later in 600 AD.
Oh, wow.
So it took that many years to come up with the notion of zero. And the interesting thing is, this is again something that I find very fascinating. The place value system was independently discovered by 4 cultures. And
so the Babylonian system, Indians and?
Babylonians, Indians, Chinese, and the Mayans.
So we all had our own place value systems.
Exactly.
And different bases probably.
Different bases, completely independent discoveries.
Wow.
So at least 4 cultures, there might be more, but at least 4 cultures independently came up with the place value system. But again, it's not still a lot considering how many civilizations, how many cultures have been there in the world.
Right.
4 is not too many. So that shows how difficult, even though it now seems so natural to us, it's clear to us how difficult this notion is, right?
Right.
More importantly, the notion of a zero was discovered only once in the history of humanity. Zero as a concept, zero as a number.
Unlike place value system, where there were at least 4 different civilizations that sort of said, hey, this is one way. Zero, it was just us.
It was just us.
It was just us who said, hey, let there be nothing also in the scheme of things. Before you get to something, many things, let's start with nothing.
Yes.
That's amazing.
So sometimes jokingly people say that India's contribution to the world is zero.
Zero.
Which they're trying to say that we did not contribute anything. But I hope that people understand the importance of our contribution. Even if zero was the only contribution, it's still a major contribution.
It's massive. It's all the identity crisis among numbers greater than 10. 44, 440, 4004, 440,444 had their own identity thanks to zero.
Make sure you check out the show notes where we share the show resources and acknowledgements. And don't forget to subscribe or like our channel for future episodes. On the next episode.
So, representing large numbers without zero was so confusing until India said, zero, just put a zero there. Isn't it? Can somebody invent that zero that says all religions are saying the same thing? It's the same thing. Wow. So zero did that to numbers.
Yes.
What nobody has been able to do for religion.
You're listening to
आप सुन रहे हैं तुम सुनो था
നിങ്ങൾ കേൾക്കുന്നത്
ನೀವು ಕೇಳ್ತಾ ಇದ್ದೀರಾ
Radio Azim Premji University.